The integers 1, 2, 4, 5, 6, 9, 10, 11, 13 are to be placed in the circles and squares below with one number in each shape. Each integer must be used exactly once, and the integer in each circle must be equal to the sum of the integers in the two neighboring squares. If the integer x is placed in the leftmost square and y in the rightmost, what is the largest possible value of x plus y? Largest, so the key there is large. You gotta go as large as possible here for x and y. Okay, well, if I want x to be as large as possible, let's start with the largest number. But I can't put that in x. I've got to put that here. That 13's got to go there. Why? Because the two neighboring squares have to add up to 13. Well, I can choose, let's see here, to add up to 13 using these numbers. 11 and 2 would work. And since I want x as large as possible, I put the 11 there and the 2 there. Now going over to the other side, same kind of story. I want y as large as possible, so I'll put the 10 here. That will help me. And then I need two numbers that add up to 10. So I'll choose 9 and 1. And since I want the y as large as possible, I'll put the 9 there and the 1 there. Now let's complete this, see what other places these numbers go. Let's say I got 4, 5, and 6 left, right? How about I put the 6 there and the 4 there? That would make 2 plus 4 equal to 6. Okay, so that takes care of that. And then, well, the only number left is 5, so obviously that has to go there. And 4 and 1 do indeed add up to 5. So this all matches. Now we want x plus y. Well, x is 11 and y is 9, so 20 is the answer to this question. If x and y are positive real numbers with 1 over x plus y is equal to 1 over x minus 1 over y, what is the value of x over y plus y over x all squared? All right, I have a gut feeling that there's some fancy algebra involved here. Fancy algebra. And basically that's when you use a little trick here and there. Let's see what we can do. Okay, so first let's just start with this guy over here. 1 over x plus y is equal to 1 over x minus 1 over y. Okay. So let's multiply everything by x plus y. And when I do that, so basically I'm multiplying the entire equation through by x plus y. This side will just become 1 then. And this will become x plus y over x minus x plus y over y. Yeah. Okay, let's keep on going here. So if I break this up, x over x, y over x, minus x over y, minus y over y. Okay. Well, this is 1, and this is 1. So 1 minus 1, that cancels. So only thing I'm left with is y over x minus x over y. Okay. That kind of looks like that, but not really. There's a negative here. If there was a positive there, I think we'd be done. But unfortunately, there's a negative, so we got to figure out what to do. All right. Well, I think that's about as far as I can go with this guy over here. So I'm gonna try to work with this now. Yeah, this is about as far as I can go without just making it back to what it already was. Okay, so let's work with this one right here. X over y plus y over x all squared. Okay, so when you expand this, x squared y squared plus 2xy y x plus y squared over x squared, like that. Okay, so this would be x squared over y squared plus this, actually I think just cancels, so that'll be just 2, and then y squared x squared. Okay. All right, so let me group these two, x squared y squared plus y squared x squared. And then this is where the fancy algebra comes in, I believe. We're going to have to factor this, but the only way to factor it is to make it look something like this is to get a negative in there somehow. So we got to get a negative. So I'll put a minus 2 plus 4. because I can't change anything, but if I do that, it kind of breaks things up a little bit. It still will be 2, right? But it'll allow me to factor, I believe. Okay, so let's regroup this. X squared, y squared. I put the minus 2 in there, plus y squared, x squared. And then just leave the 4 out here. Yeah. And I think this could factor. Yeah. So before I factor it, let me put in this type of scenario there. So x over y and y over x, which is essentially just 1, but if I put it in there, it makes it a little bit obvious as to how this can be factored. And this factors to x over y minus y over x, all squared. These 3 terms. And then we got this 4. Is that right? I think so. Okay, great. So now, well, this right here is not quite like that. I think very similar. I think this would be, if we multiplied both sides by -1, it would look exactly like it, like that. Yeah, so that is -1. So we got a -1 in the bracket, and then plus 4. And that's just 1 plus 4, which is 5. So on the exam paper, since you have to put 2 digits, you would put 0, 5 as your answer. For each positive integer n, define s at n to equal the sum of the digits of n. For example, s at 2023 is 2 plus 0 plus 2 plus 3. The number of integers n with n between 100 and 999 inclusive, and s at n between 7 and 11 inclusive is s. What is the integer formed by the rightmost 2 digits of s? So let's make a list here. We have n and s at n. And n is between 100 and 999. Oh, that's a lot. So obviously I can't go through all of them, but let's see if I can get some sort of a pattern. Let's start with 100. S at n would be 1. 101, S at n would be 2. 102, S at n would be 3, and then so on. But we're only interested when S at n is between 7 and 11. So let me just fast forward to 106, which would make it 7, sum of the digits, and then all the way to 109, which would make it 10. And I think that's the highest we can go before we get to the next block. Yeah. So this would give me 7, 8, 9, 10. So that's going to be 4. Let me just put that in a little circle there. Then we're going to go from 110 to 111. Oh, sorry, 110 to 111. 110 to 119, actually, which is the next set of 10. And that will give me, I will be able to get sums of 7, 8, 9, 10, 11. Like, let me write it out. So I'm going to skip over the ones that we don't care about. I'm just going to go to 115, which is 7. And all the way to 119, which is 11. So this is going to give me 5. 5 n's for which s at n is between 7 and 11 inclusive. Okay, so a long way to go, but hopefully there'll be a pattern here. From 120 onward, I think it's the same thing. You're going to have 124, is that 7? And then all the way to 11 would be another 4, so 128, I believe. And that's going to give me another 5. Yeah. Wait, let me see if I did this right. 124 is 7. Yeah, 128 would be a sum of 11. Okay, so I think we're going to have to go a little bit faster than this, but I just wanted to do it slowly, because otherwise you wouldn't understand. Okay, so now the next one, 130 to 139, we're also going to get 5. And then 1... 140 to 149, we're also going to get 5. And then 150 to 159, we will get 5. And then 160 to 169, I think we'll get 5 again. But 170 to 179, we will only get 4 because it starts with 170, right? And the sum of the digits of 170 is 8. So we can get 8, 9, 10, 11, but we can't get 7. That's why it's only 4. And then 180 to 189, we'll only get 3. And then 190 to 199, we'll only get 2. Yeah. So for the hundreds, if you add up all these guys, that's actually 43. Okay, so that took a long time. I'm hoping that the 200s won't take as long. 200 to 209, I think it's 5, and you can easily verify that. 210 to 219 is 5. 220 to 229 is 5, and so on. And I think 250 to 259 is the last time you get 5. And then once you get to 260 to 269, you only get 4 because 260, the sum of the digits is 8. So you will never get a sum of the digits of 7 in that 10 range. And then 270 to 279 would give you 3. 280 to 289 would give you 2. And then finally 290 to 299 would give you 1. And this is 40. And then I'm just going to do, I think I can just do one more. 300 to 309, that's 5. 310 to 319 is 5. And then for this one, I think when we get to 340 to 349, I think that's the last time you get 5. And then starting with 350 to 359, you'll get 4 because 350, the sum of the digits is 8, so you don't get a 7. And then 360 onward is 3, 370 onward is 2, 380 onward is 1, and then 390 onward is 0 because 390 itself has a sum of 12. So this adds up to 10 plus 15. I think, I skipped a few, so I got to make sure I add those. So 10, 5, and then the 20s and the 30s. So 10, 20, 30, 35. Yeah. Okay. Well, I see a pattern that it's going to go down by 5. Yeah, and you can verify that. So if you go 400, all the 400s, 400 to 499, all of those, that's going to be 30. Yeah. And then similarly, if you go 500 to 599, that's going to be 25. And then 600 to 699, that's going to be 20. And then the 700s, that's going to be 15. The 800s would be 10. And then the 900s, this is, I think, the trickiest part because this one doesn't follow the constant rule, I believe. And you can verify that. Let me just manually write them out, the ones that would fit our criteria. 900, 901, 902. That would give me sums of 9, 10, and 11. 910, 911, and 920. These are the only ones that would give a sum of the digits between 7 and 11. There's 6 of those, so there's 6 there. So we got to count. This 43, this 40, this 35, this 30, 25, 20, 15, 10, and 6. 43, 40, 35, 30, 25, 20, 15, 10, and 6. And when you do, the grand total is 224. And they want the integer form by the rightmost two digits of s. This is our grand total s. The rightmost two digits are 24, and therefore 24 is the answer for this question. Quadrilateral ABCD has angle BCD equal to angle DAB is 90. The perimeter of ABCD is 224. Its area is 2205. One side of ABCD has length 7. The remaining three sides have integer lengths. The sum of the squares of the side lengths of ABCD is s. What is the integer formed by the rightmost two digits of s? All right, so we have a lot of information here. First, we have this rectangle AB. Well, hold on. I actually don't even know. Oh, it's just a quadrilateral. I thought it was a rectangle. So obviously, oh, but we are given some clues that BCD and BA and DAB are right angles. But it's not necessarily a rectangle. Okay, I think I understand. So let me just put in those right angles. So I think it'll be something like this. So this is D right here, this point, and this is A, and this is B, and then this is C. So BCD is 90 and DAB is 90. Okay, and then I'll just connect B to D like that. And let's see here. Let's put in all our information. Perimeter of this is 224. Okay. And I'm going to label this, actually. I'm going to label it, it doesn't really matter how you label it. I'm going to label that A, B, these sides, C, and D. Doesn't really matter what order you put them in. So the perimeter is 224. So that basically means that A plus B plus C plus D is 224. And then the area is 2205. So 2205 is 1/2 base times height for the first, plus 1/2 base times height for the second. Yeah. And then I guess I'll just multiply through by 2. And I don't know if that helps at this point, but it'll just get rid of the fraction before 410 is BC plus AD. All right. Now, where do we go next here? Let's see here. Well, I guess we can use the fact that these right angles, that will create a Pythagorean relationship, that b squared plus c squared is the hypotenuse, but that hypotenuse can also be written as a squared plus d squared. And that's basically coming from Pythagoras. And anything else? What are they asking for? What is the integer formed by the sum of the squares of the side lengths? Okay, so what they want us to figure out is the sum of the squares of the side lengths, which would be a squared plus b squared plus c squared plus d squared. And they're saying that is s. Okay, so I'm just trying to put everything together here. And, all right. Okay, so where do I go from here? Well, I think there's only one piece of information I haven't put yet, and that's the length is 7. One side is 7. So I'll just make one of these sides. I don't think it really matters which one. They don't specify which one. So, I don't know. It doesn't really matter. Let's just make that one 7. So let's just say B is 7. So as B is 7, I'll put that in everywhere I can. So that means this guy would basically be that 7C plus AD is 410, correct? Okay. And then here, this guy would basically be A plus C plus D. Well, I didn't put it in the 7, but it was 7 we can subtract from the other side, and that'll just give me 217, right? And anything else? Oh, over here I can put a squared plus 7 squared plus c squared plus d squared is s. And I think I'm pretty much... Oh, and then over here, I can put 49 plus c squared plus a squared plus d squared. All right. Let me just circle. Got a lot of equations here. But as long as we have 4 equations with 4 variables, but I don't think we do. Yeah, because now we got that s in there. All right, let's just keep going here. Hopefully something will work out. Okay, so now where do we go from here? I'm going to start, let's just start with this 4410 guy. This 4410 is 7c plus AD. Now, with this formula right here, I can isolate for something. I'll isolate for c. From that formula, if you isolate for c, c would be 217 minus a minus d, right? So I'm going to plug that in there. So we got 217 minus a minus d plus AD, like that, 4410. Yeah. Okay. And I think now we can probably progress to something. Let's expand this all out. 4410 is going to be 1519 minus 7a minus 7d plus AD. And then let's see here. I guess we put the 1519 on one side, and when you do, you get 2891 is equal to AD minus 7a minus 7d. And then I guess I can factor. I can factor an a, and I get d minus 7 minus 7d, 2891. And I think if I were to factor, if I were to do a little bit of fancy algebra here, add 49 and then subtract 49 like that, I'd be able to factor these two. So this minus 49 I'll bring over to the other side, so make this 2940, and then that minus 7 I can factor out and then get d minus 7, and therefore I'll get d minus 7 and a minus 7. So that makes it a little bit better. Okay, so that's about as far as I can go there. Okay. All right, so I've got two numbers that multiplied together to give 29 and 2940. Now, that list is a very long one, so we've got to come up with some sort of way of narrowing that list down. And I think we can narrow it down with this fact right here. Since c is equal to 217 minus a minus d, and obviously c is a length, so c is greater than 0, that means that 217 minus a minus d is greater than 0. I hope that makes sense. And therefore, 217 would be greater than a plus d. So a plus d is less than 217. So that helps us shorten this list down, because you're gonna make a table, right? You're gonna make a table to do this. You're gonna have, let's just make that table. We're gonna have a minus 7, and then you're gonna have d minus 7, and then we can figure out a and d pretty easily. And then a minus 7 times d minus 7 has to equal 2940, so that's the way you choose it. And then you can figure out c, which was up here, 217 minus a minus d. That would be a pretty simple calculation. And then finally we can figure out what it is we really want to figure out, which is this guy. Wait, is that what we're trying to figure out? And we have to also satisfy this guy right here. And I think this was, sorry, this is an equal. I don't know why I put a plus. And to satisfy that guy, that means that a squared plus d squared minus that c squared has to equal 49, right? According to that. So this is what we have to test. And then let's see what we get. Let's see what we have. Now, the big challenge for this is that this has so many different values. I mean, it's a long, long list. But the good news is that we can use this to narrow it down. We can go a little bit further. Since we're looking at really a minus 7 and d minus 7, we can put the minus 7s in there. And then when you do that, you actually get 203 on this side. So this helps narrow it down. Now the list is very long, but when you narrow it down, it comes to just 7 pairs. 20 and 147, 21 and 140, 28 and 105, 30 and 98, 35 and 84, 42 and 70, and 49 and 60. So all these satisfy that little rule there. Okay, finding A is fairly straightforward. 27 and 154. And let me just fill this out. 28, 147, 35, 112, 37 and 105, 42 and 91, 49 and 77, and finally, what do we have? The last one, 56 and 67. So those are our table, and then the C, that's a pretty straightforward calculation. 36, 42, 70, 75, 84, 91, and 94. Okay, now these guys, I'll let you calculate it all, and I just put them in like that. Now, the key here is that a lot of these are not going to be used because this has to be equal to, let's just keep it in the screen here, this guy. It's got to be equal to 49. So the only ones we can use is 49. Now this one is 49, but unfortunately all the other ones don't add up to 49. So they're not going to be the correct answer. 629 and finally 23149. Okay, so the only one that works is this guy right here. But we're still not done. We still have to satisfy that b squared plus c squared is equal to a squared plus d squared. And we still have to see if it satisfies this Pythagorean relationship, which is that a squared plus d squared is equal to b squared plus c squared. So let's see. Only for this guy. So we have a squared plus d squared, and then that has to equal b squared plus c squared. Well, let's see with those numbers. We have 49 squared plus d squared, which would be d is 90. No, sorry, d is 77. And then on this side we have 7 squared and c is 91 squared. And both of these sides equal 8330. So that is satisfied. And now we just have to figure out s, which is a squared plus b squared plus c squared plus d squared. So let's plug in those numbers. We got 49 squared plus 7 squared plus 91 squared plus 77 squared. And that works out to 16660. And they want the rightmost two digits, which are 6 zeros. So 60 is the answer to this question. A cube has a length of 4. One end of a rope of length 5 is anchored anchored to the center of the top of the face of the cube. The area of the surface of the cube that can be reached by the other end of the rope is a. What is the integer formed by the rightmost two digits of the integer closest to 100a? So we have a cube, and let's just put a little diagram first and let's see what happens. So we got this cube right here, and then of course you're going to have this rope. It looks like it's attached to the top, and it's full. How long is it? 5 meters. Now the cube has length 4, so that makes a very interesting situation, that it would be able to come down. That's going to be 2 because it's halfway down, right? It's in the center of the top face. So that's 2, and then it'll come down another 3. Similarly, on the side, it can go down another 3. But then on the diagonal, it wouldn't come down 3. It would come down sort of partially like that. And then it would kind of be one of these curves. Now, I think it's easier to understand it if you open the cube up. And so let's just make this the top face, and then we'll put in the other faces like that. And I think it'll be easier to understand. Okay, so now we've got this cube, and it has this rope, and the rope can basically go around pretty much like a circle. So it would go to here, it would go to here, pretty much a circle. Yeah, you guys get it. Where this is the center, and the radius of the circle is 5. So all the way around like that. Got it? Now, I think a lot of this would be fairly straightforward, but some of it would not. And let me explain. I think if we cut these little shapes like that, it's not really drawn to scale, but I mean, you guys get the point. And let's finish it off up here. You'll notice this part here, that is sort of like a portion of I guess a circle, but the rest are just rectangles. And because the rest are just rectangles, those will be very easy to calculate. Now the portion that's a bit of a circle, that we'll calculate later. So let's first do the easy stuff, and then we'll do the hard stuff later. So the first part of the cube that I'm going to, or the shaded, I guess this region A that I'm going to talk about, is the center. That's part of region A. And because that's part of region A, it's very easy. That part is just a 4x4 because that's just the side length. So that's 16. So there you go. There you go. That's the part of A. I think that's the easiest. And then the next part of A I'm going to concentrate on are these rectangles right here. These rectangles, they're all equal. They don't look equal because it's not drawn to scale, but you guys understand. And there's 4 of them. So I'm going to write 4 for now, and then I have to calculate each one. Now each one, if I were to put one of them on the side like that, the length is 4, we know that. But this side we don't know just yet. But we can figure out the side pretty easily, I think. And you can figure out the side pretty easily by drawing a line from the center to the corner like that. And then just concentrating on that triangle, I'm going to put that triangle over here. Well, from here to here, the hypotenuse of that triangle is basically 5, right? That's the extent of the rope. And then from here to here, well, that's just 2 because that's half of the length of the side of the cube. So using Pythagoras, we can easily figure out the other side. The other side, if it's, let's say, x would be 5 squared minus 2 squared, x squared that is, and therefore x squared would be 25 minus 4, which is 21, and therefore x is root 21. And root 21 is approximately, I'll keep it to 4 decimal places, 5825. 5825. I'll put in another decimal place. But we're not interested in that whole x. We just want from here to here. We just want this guy. We want from here to here. So that's going to be x minus 2. So this guy is x minus 2. And that calculation is 2.58257. And therefore the area of that triangle, or sorry, rectangle, would be 4 times 2.58257. And when you do that math, you get approximately 10.33. And the exact value is 10.3303, because I'm trying to get it as close as possible. And when you multiply it by 4, since there's 4 of them, you're going to get 41.3212. All right. So we got a lot of this so far. The only thing we need now are these little caps here. So I'm going to draw this segment right here over here. So that segment is kind of like a pi segment. And what I'm interested in is this guy right here. So I'll just call that segment that I'm interested in the cap. And the cap plus the triangle is the full pi. Right? Now, what I do need, of course, to figure this out is this angle in here. That's really going to help me. Without that angle, I won't be able to. Okay, I think I can figure out that angle. That angle actually is double of this guy, which is this, so this would be theta over 2. I think that's right. Yeah. Yeah, I'm pretty sure, because it just comes from that same triangle. So I can use trigonometry on this triangle to figure out theta over 2. So I guess I'll use tan. Tan of theta over 2 would be what? Opposite over adjacent, right? So it'd be 2 over x, and x is 4.58257. And you're allowed to use calculators on the Canadian exams. So when you do this, you'll get theta over 2. When you do the inverse tan, 23.57082, I believe. So theta would be double that, which is 47.1564. Okay, great. So now I can figure this out. The cap is going to be the pi minus the triangle. And the pi, you figure out, it's a segment of a circle. So it would be pi r squared times the segment, which is theta over 360. So in this case, it would be 47.1564 over 360, because that's how much of the circle it is in terms of degrees. And then the triangle, I guess we just use 1/2 base times height. This triangle, the base, I believe, is 4, and the height is x, right? Yeah, so the base is 4, and the height is x, which is 4.58257. Yeah. And then what's r? This r, oh, r is, oh, I got it. R is this thing. So that's just 5. Yeah. So I just plug in 5 for my r. So this is going to be pi 5 squared times this 47.1564 over the 360. And then minus that, well, I guess it'll just be 2 times 4.58257. And then when you crunch out all these numbers, you get 1.12278. Now, keep in mind that we have 4 of them, right? 4 of these caps in the diagram. So we got to multiply that by 4 then. So we got to multiply 4 times this 1.12278. And when we do, we get 4.4911. So my A is this guy plus this guy plus this. And when you add up all those guys, you get approximately 61.8 812. Now they're asking us for 100A. So 100A would be 6181.2. And the integer closest to that would be 6181. And then the rightmost two digits, I guess, would be 81. So the answer to this question would be 81.